All right, welcome to Friday Eve homework help. Here we go. I'm going to do number 5. So it says multiply the two binomials. Your answer should have 3 terms and be in the forms ax squared plus bx plus c. Okay. That's what we've been doing. Sorry, I'm reading the little blurb at the beginning. Okay. So, here we go. It's like distributing with 2 steps. So for now, I'm going to start with my 3x. You can ignore the negative 5. Here we go. 3x times x, 3x squared. Because x times x is x squared. Okay, you have 3x, times negative 1. Negative 3x. And then you have negative 5 times x. Oh, sorry, I'm getting ahead of myself. We're done with the 3x. Moving on to negative 5. Okay. Negative 5 times x, negative 5x, and then negative 5 times negative 1, and negative times a negative is a positive 5. Okay? And now you combine your like terms. Where is my purple marker? There it is. Okay. So this is the only term with an x squared, right? There are no more x squareds. So just rewrite this. 3x squared, negative 3x minus 5x. Be careful. Negative 3 minus 5 more. John took away 3 of my apples, and then he took away 5 more. So he's taken away 8. Negative 8x, and then 5 is the only constant. There's no other number without an x, so just rewrite it. And that is your final answer. Okay. All right, this is number 9. 8x minus 3, that's an 8. 8x minus 3 times 2x minus 1. Okay, so once again, take it one step at a time. So I'm going to start out with my 8x, start out with distributing my 8x, so I'm going to ignore the negative 3. Here we go. 8x times 2x, well, 8 times 2 is 16. X times x times x squared. And then you have 8x times negative 1, negative 8x. All right, we're done with the 8x. He has done his job. All right, so now you move on to the negative 3. Distribute negative 3 times 2x. So negative 3 times 2 is negative 6. And then don't forget your x. Okay. And then you have negative 3 times negative 1. Negative times negative is positive, so positive 3. And now combine your like terms. This is the only x squared, so just rewrite it. 16 x squared. And then you have negative 8x minus 6x. So once again, I took away 8 cell phones. Ha! And then I took away 6 more. Negative 14x. And then your constant is a 3, and he's the only one without an x, so just rewrite him. And that's it. All done. Okie dokie, this is number 10. So it says, use first and second differences to identify the pattern in the tables as linear, quadratic, or neither. Write the recursive equation for the patterns that are linear or quadratic. I'm going to give you a hint here. They're all either linear or quadratic. None of them are neither. Okay, so here's number 10. So first things first, is it linear, or do we have to figure out the first difference to see if it's quadratic? Well, actually, the first difference, we can just figure it out anyway. The first difference is negative 23 to 17. You're adding 6, so plus 6. Negative 17 to negative 11, plus 6. Negative 11 to 5 to negative 5, plus 6. Ooh, you guys need to come up higher than that. Or maybe not. I just looked and that was a bad angle. Negative 5 to 1, you got a plus 6. 1 to 7, plus 6. 7 to 13, plus 6. So your first difference is constant, right? So this is linear. So then I think we just have to write a recursive. Do we have to write explicit? Nope, we just have to write recursive. Okay, so then you can either write f of x or f of n. I've been doing f of x, so I'm going to stick with that. Equals f x minus 1. So remember, this just means previous term. This is always how you write previous term. Or you could write it n minus 1. That's probably how you did in IM1, but it doesn't matter. They're the same. Okay, they mean the same thing. Just make sure they match. So if you use x, always use x. You can't, like if you did f of n equals f of x minus 1, all of a sudden that doesn't make sense. Your variables have to match. So x and x, or n and n. Okay. Anyways. So then your previous term, and then what are we doing to the previous term? We're adding 6. Okay. So, oh, we didn't say this. This is linear. So you would write linear, and then you would write your recursive equation, and I think that's all you do. Yes, yes it is. Okay, doke, this is 14. The glare is right on this number, that's a 6. Hold on one second. Experiment time. There, I just turned off the lights. Okay, there goes the glare. Anyways, oh right, is it linear or is it quadratic? All right, so let's figure out the first difference. Okay, so let's see. From 48 to 22, that is subtracting 26. Did I write that down right? 48 to, yep, okay, all right. So we're subtracting 26. Then from 22 to 6, we're still subtracting. I can't do math. 16. And then from 6 to 0, we're subtracting 6. From 0 to 4, that one's not right. That should not be a 4. Oh, it is. Oh, no, that does make sense, because now we're adding 4. Okay, we're good. Oh, plus 4 or just positive 4. 0 to 4, and then 4 to 18, 14, and then 18 to 42, 24. Okay. Cool. Well, if the first difference is constant, then it's linear. like our last problem, but it's not. Our first difference is not constant. But now ignore this for a second, ignore the middle data. Is our first difference linear? So then let's find the second difference. Sorry, I got a little sloppy. Second difference, negative 26 to negative 16. We're adding 10. Negative 16 to negative 6. We're adding 10. Negative 6 to 4. We're adding 10. 4 to 14, we're adding 10. 14 to 24, we're adding 10. All right. So, yes, the first difference is linear because it's going up by 10 each time. The first difference is linear because it's going up by 10 each time. Okay. So we know it's quadratic. As soon as we figured out that the first difference is linear, we knew it was quadratic. So it's quadratic. Okay. Okay, so we know, now you're just thinking in terms of, you can think in terms of the first difference. What's our linear equation for this? Well, our slope is 10 because it's going up by 10 each time. Okay. Should I make it separate? I can make a separate table. Let's do x, f of x, -3, -2, -1, 0. Okay. So nothing goes with the -3. Our first difference is -26, and then -16, and then -6. Okay. So actually, because this should, we're making a y equals mx plus b equation for this, right? Y equals mx plus b. So our slope is 10, and b is our y-intercept. Well, if we look at our table, what is our y-intercept? When x equals 0, what is y? Look at my shadow. Sorry. When x equals 0, y is -6. So you can just plug that in. You can test it for sure. So you would multiply, let's see if it works. So 10 multiplied by your y value, so 10 times -2 equals, okay, -20, but I need it to be -26, so I subtract 6. Hold on. There we go. Okay. You multiply your slope times another y value, -1 equals -10. But when when x is -1, y should be -16. So you also have to subtract 6. 10, which is your slope, multiplied by a y value, 0. 10 times 0 is 0, but it's supposed to be -6, so I subtract 6. Okay, so that would be our equation for the first difference. That is the linear equation for the first difference. So then, your quadratic recursive equation is f of x equals, or f of n, f of x minus 1, that just means previous term, and then what are we doing in the previous term? 10x minus 6. Okay, and you could test that. Do I still have it up? I do. So okay. you could test that. So let's pretend we didn't know this one or this one. Okay, so I want to figure out what is f of x when x is 2. So I'm going to substitute 2 in here. F of 2 equals f of 2 minus 1 plus 10. Another x. Everywhere you see an x, you're substituting in 2. And then minus 6. Okay. So f of 2 minus 1 is just f of 1 plus 10 times 2 is 20 minus 6. Right. F of 2 equals, what is f of 1? This is saying x equals 1, what is y? F of 1 is 4. 4, and then 20 minus 6, 20 minus 6 is 14. Oh yeah, we're good. So then f of 2 equals 4 plus 14 is 18. Oh, I erased it, but that's what it was. Yeah, so this was 18, and this is 42. Okay, so we tested our recursive equation, and it does indeed work. We got when x is 2, y is 18. Okay, you don't have to test it. I'm just showing you why it works. Whew. Okay, this is number 17. So for 17 through 20, it says, interpreting recursive equations to write a sequence. Write the first 5 terms of the sequence. Okay. Well, they tell me f of 0 equals negative 5, and then they give me f of n equals f of n minus 1, previous term, plus 8. So this is where we start. So our first term, well, this is actually the 0th term, but the first term they give us is negative 5. And then, how do I figure out the rest of them? They gave me negative 5 to start, but now what? You take the previous term and you add 8. So then negative 5 plus 8, 3. 3 plus 8 is 11. 11 plus 8 is 19. And then 19 plus 8 is 26. Go. $27. And that was this one, 5. 1, 2, 3, 4, 5. Okay, so that's it. I'll do one of the other ones. All right, number 20. So same thing. We have to write the first 5 terms, and they give us a recursive formula or equation, whatever. So f of 0 equals 6, and then they have f of n equals 2 f of n minus 1. So once again, they tell us where to start. We start at 6. Right? And then, how do we figure out the rest of the terms? What does this 2 mean in front of f of n minus 1? Because we know this means previous term. So what's the 2 mean? It means you're multiplying by 2. So your previous term times 2. And then 12 times 2. And then 24 times 2. And then 48 times 2, and that's all 5. So that's as far as you need to go. Okay, I think that's it.